do that. Okay, so welcome everyone. Thank you for joining us today. I suspect a few people will be going to join us over the next few minutes. So today is our first large-scale SIG virtual meetup. It's a new format that's a bit more informal than the things that we've been doing so far, which were much more produced over StreamYard and posted on YouTube Live and all of those things. The goal is really to have a discussion between operators of OpenStack deployments and people that have been operating large-scale OpenStack environments so that we can all learn from each other and ask a lot of questions. And so it's much more of a free-form discussion than it is like a presentation or like a conference or a panel or anything. So Kevin is our special guest for today. He's going to talk about the Rackspace cloud and history and the current deployment and what they are using and the challenges that they encounter and the choices that they've made, all those things. And we'll be able to ask questions. So my co-hosts are Arnaud Morin and Felix Wittner, and they will drive most of the technical discussion and try to keep us on pace on interesting topics, but we'll certainly pose for more questions from the rest of the audience so that you can all engage more directly with Kevin and ask any questions you're interested in. To start, maybe it's a good opportunity for you, Kevin, to tell us more about Rackspace, the Rackspace cloud, the history, obviously the very long history that Rackspace has with OpenStack, what the current deployment looks like compared to the history, the original deployments that we've made, and well, give us a bit of context so that we can get started.
Sure, appreciate it. Well, hello everybody. Good morning, good afternoon, good evening, good night, whatever. Anyways, yeah, I'm really happy to be here and talk and share what we're doing with OpenStack, share what we're doing at Rackspace, and kind of reintroduce ourselves. We've been absent for a little while. So, anyways, my name is Kevin Carter. I'm the product director for our OpenStack private cloud business unit, which spans our on-prem OpenStack environments as well as our public-facing OpenStack multi-tenant environment, right? And so I guess I'm gonna try to share my screen here. Hopefully, I can do a slideshow thing and we'll prime it with some PowerPoint, speaking the language of my product director people. So hopefully this is coming through. Yeah, I'm not gonna go into presenter mode. I'm just going to click through the slides and we'll rapidly go through them. But yeah, talk through the years, right? So Rackspace is 25 years old, right? We've been around for a minute, and we were there, at the original release of OpenStack and put OpenStack into production in 2010. Released in 2010, put it into production in 2012, and we've been running that OpenStack public cloud ever since. And I'll get into the size and scope of what it is today and where we're taking it. In 2023, as you can see, there's some points, right? 2012 to 2024, and there's missing bullet points there, but it's because we were running it, but we have been on this kind of unique path for OpenStack as a whole. And while it is an OpenStack public cloud, it is using the OpenStack APIs. We're quite divergent, and from our current OSPC public cloud environment. However, in 2023, we set on a path to reintroduce ourselves and become more aligned with the community, and actually quite literally to reintroduce ourselves as a large player in the OpenStack environment. And that starts with our OpenStack Enterprise, and we're taking that feature, that functionality that we have, and making it public, right? We're taking our private cloud public is what we'd like to say internally, right? But moving on from that, this is what we have today. It's 7 data centers worldwide, around 28,000 hypervisors. 117,000 total virtual machines and 152 petabytes of cloud, of storage. And that's shared between block and object storage. And our block storage, I'll talk about where we're a little bit divergent from some of the other things, but this is all using our object store is Swift. There's under the hood, there's some Hummingbird components in there. People remember that fondly. But for under the hood, it is Swift, and it is the Swift APIs. Our virtual machines is Nova, right? Through and through Nova, but it is also using Nova with Zen Server. Again, mistakes were made along. They were probably the right. If we look at it from a historic lens, the choice of Zen Server was probably the right choice in 2012. The problem that we have run up against time and time again is that we have not revised that choice throughout the years, right? And so we've been maintaining this kind of system on our own. And so it actually kind of plays into why we've been absent for a little while, right? Is that we were in the OpenStack ecosystem. We were doing a lot of code contributions. We were participating in projects, but it wasn't informing what we were doing inside of our public cloud, our multi-tenant public environment. And so what you see in there is, like our network stack is using Melange. And if you scratch your head and think, what's Melange? We'll go Googling and you'll find it. But I mean, Melange was effectively produced as a network provider at around the same time that Quantum was produced. And the community went with the Quantum approach. Unfortunately, we had already begun investing with Nicira, and Nicira eventually was purchased by VMware, which then became NSX. But we were using this Nicira controller with this Melange component, and we quite frankly, we still are. We're just on the hook of maintaining it ourselves. The same is true for like our block storage systems, right? Back in the day, it was all a big part of Nova, and then it all became kind of segmented out, became Cinder. But we had Lunar, which was, again, if you're scratching your head like, what's that? There is a spec out there. You can go find it. It's out on the internet, but it is effectively the competitor to Cinder. It does a lot of the very same things, but it is being done in a very unique Rackspace way. So, like I said, the 2023 offering, when we came back into this, we basically took a long, hard look at ourselves and said, how do we do this better? Now, our OpenStack enterprise business has always been aligned to the OpenStack upstream. It's largely deployed with OpenStack Ansible. Like top to bottom as is. We have some customizations in that, but it is the core components inside of it are OSA. And so it is tightly aligned to OpenStack itself, but our public cloud wasn't. And so my boss, Josh Villarreal, is combined our different teams, put us on a mission together and said, we need to basically create a comprehensive portfolio of platforms and systems that everybody aligns on. And it needs to be, at the time when we started this in our product requirements documentation, we actually wrote that the first sentence needed to be that all of our OpenStack ecosystems need to be RefStack compliant. Now, RefStack has since been retired. But I mean, that is like, again, it was the first sentence of where we were starting with how we were combining our business units. So that's where we are with OpenStack Flex, right? With our Dell peoples, but we're pretty tight with Dell, and we're building everything out using our Dell hardware at this point. But OpenStack Flex is the core components of what we're building and how we're building it. And so it is upstream open source OpenStack. We are using Kubernetes for a lot of the underlying infrastructure and components itself. We have begun using OpenStack Helm as some deployment tooling under the hood. We're using a lot of Customize to ensure that we can make changes as we see fit. And we are aligned to the Slurp releases of OpenStack itself. So right now it's running Caracal. That is the new OpenStack Flex public cloud offering that we have. It's available in one data center now and two more by the end of this year, which is coming soon. It'll blanket North America with our new product offering, and it is all on this OpenStack Flex environment. So the cloud in view, there's a QR code. You can scan it, and that'll take you to our public docs. But what this looks like is a fairly what we're trying to do is build a simple ecosystem that is easy to maintain and scale. And there are a lot of moving parts. And the joke is that I said simple, but I also said Kubernetes, and there's that. But we are running this at fairly large scale today. Like I said, it is active and online in one data center on the West Coast in San Jose, coming to DFW, Dallas, and Virginia by the end of the year. But it is a sizable new footprint on this new platform. And the whole point of this is to have tight integrations between what we can do inside of a container ecosystem, as well as what we can do inside of the OpenStack ecosystem. And so it is a portfolio expansion. We are taking our enterprise private clouds and making sure that we can also deploy public clouds with that. And that QR code that I pointed at, which goes to docs.rackspacecloud.com, is quite frankly everything that we have done for our public and private clouds for building this all out. And so it is 100% being built in the open. There's no hidden secret sauce here. Even our customizations are public in GitHub and et cetera. There's a private repository of the different data centers that we have online for the different systems and services, but the tooling itself is 100% public. And then the rest of this is marketing, and so we don't really need to get into it. But for the final portion of this deck is that like I mentioned, as I started, we were there and early on, and there's a section of time where we were missing, but we're back now, and we're back in a pretty big way. We've convinced our company to not only invest in the platform, the technology, but also in the foundation. And so coming back as a platinum sponsor of the foundation, coming back and making sure that our rackers are plugged into the upstream ecosystems. Hopefully you guys have seen Doug Goldstein cruising around, as a recent elected TC member. Josh Villarreal, my boss, being a part of the board. I threw my hat in the ring as also trying to become a member of the board as well, but also trying to get our engineering teams plugged into the upstream, right? I've got like Samia working on some Skyline stuff, and she's got a couple commits into Heat already, and again, like reintroducing these engineers that have largely been independent, operating in isolation, working on those systems that we've been maintaining in isolation, like Melange and Lunar and a few others. Tasker is another one, but they've been building these things out independently of the rest of the community and trying to reintroduce them in the community, teach them about Garrett, and make them comfortable in working in that space. And so you haven't seen a huge push from our teams just yet, but it is happening. It is happening as incrementally as we go. But that is the end of my deck. I will stop sharing, and just as a primer for where we've been, where we're going, and I'm happy to actually just engage with folks and talk about what we're doing, where we're going, point you at other things that we may be doing, or take feedback on things that we've done terribly. So, anyways, that's that.
Oh, thanks, Devin. It's the trip down memory lane was interesting. Right. The Melange and Hummingbird. I haven't heard those words for a while, so
they're still there. But
refreshing my memory.
Yeah,
I have like dozens of questions, but I'll let Arnaud and Felix ask they probably have some as well, so I don't want to.
Fire away.
Yeah.
Go ahead.
Yes, thank you, Kevin. Amazing presentation. I was not there at the beginning, so I remember about Rackspace being a very big OpenStacker at the beginning. But yeah, that's great to see you back. Thank you.
It's great to be back, but thanks.
Yeah, it's great. Yeah. So for now, you said it's 2 regions, right? You have 2 regions available?
We have one online right now.
One online.
And we have 3 that are, well, they'll be online here in 2024. So.
And it's pure OpenStack upstream code, right? You try to stay on that now.
100%, yeah.
100%.
We're using the code as it is. We have written some plugins, but even the plugins that we have written are on Racker Labs GitHub. Mostly the plugins that you'll find are things like integrating into our auth, right? We want Keystone v3 to have Keystone v3 for net tokens, but we also want our existing install base, our existing customers, to be able to use their credentials and log into our new cloud. And if you've done any research on what our auth system is, it is Keystone-like, and it uses the v2 spec, right? And that is how the OSPC, the OpenStack public cloud auth capabilities work. And so the tokens are not, well, they're not interchangeable. They don't work together.
Yeah.
And so we created an auth plugin to make it so that they'll work together.
It's kind of a federation between the old Keystone and the new one, something like this.
It is exactly that. We're quite literally leveraging the features of Keystone Federation as an auth plugin for the new platform.
Okay, nice. Do you plan to, if I understood correctly, correct me if I'm wrong, but you have your old OpenStack running on old software, and the new one, do you plan to upgrade the old one, or is it something you will trash at the end and deploy new stuff anyway?
We're bringing in new hardware and new software, and we're standing it up alongside of the old environment, and then creating a way for the old customers to move their workload into the new environment. Yeah.
So there is no
we're not gonna
in place.
It would be really hard to upgrade in place on some of these systems, as well as the fact that it's, like I said, it's using Zen server, right?
Zen.
So it's like the conversion of Zen to KVM is not something that we would be able to do in place, but we are standing up a parallel hardware and then again creating a migration strategy and story for our customers to opt into, right?
Okay.
Yeah, we did a similar thing a few years now ago from back then OpenStack Queens to OpenStack Yoga, and from OVS backend to OVN backend. So similar story online, doing that online.
It's rough.
Might be possible, but it's probably not worth the time.
It's rough. It's rough. It's a similar, very similar situation, right? Yeah. Like the OVS to OVN, right, is something that you can do online, but there's risk, there's impact, right, to the workloads, and
there's a different definition of online for that.
For right. Going from the other big here, if you look at it from a topology point of view on the instances, our legacy environment, our existing OSPC public cloud, multi-homes every one of our instances. Right, there's an internal network and then there's a public network, and each one of them get a public v4 address. As we are pushing everything into an OVN space, very similar to what you're doing, we're leaning into tenant networks, right? And so we have layer 2 for some internal access, but everything else is mostly layer 3.
It makes everybody's life also a lot easier, I think.
It from a project point of view, it does, because we can move over workloads, we can mirror networks really easily, we can create lots of tenant networks that all have the same 10 dot space if they want it, right? We don't have to worry about, are we running out of VLANs? There's a lot of advantages there. Operationally, there's some disadvantages, right? The Melange ecosystem that we have with that multi-homing is really well understood, at least by our operators. It's fairly simple from just an overhead point of view. But it lacks the features that modern customers need and want. So there is a transition that is happening there, but it's baby steps. Yeah.
Maybe I have one question about what were your motivation to come back and to reinstall something from a stream, because it seems, based on your scale, your previous stack was working correctly. I mean, your Zen and OVS stuff seems amazing.
It works.
It works.
Yeah.
What is your key decision to come back to a pure upstream OpenStack environment?
There's a few actually, but I think the really it's so our enterprise business, right? The enterprise side of this, there used to be two different businesses that didn't talk to each other. In fact, Thierry, you probably can remember, but I mean, there were times where I was on the private cloud side and I would go to conferences where our public cloud side was talking and like heckle them, you know,
like two companies.
Yeah, like like we were like warring factions, right?
Okay.
Because we had two different like fundamental ideas behind how to run this ecosystem. And so one of the big things is that, you know, now we're in a position where we need to we want to combine. We want that to stop, right? We want those teams to actually work together. And so there is like I mentioned, we're taking our private cloud and making it public, but there truly is a lot of change that's happening on the private cloud side too, to adapt to, you know, some of the scale limitations and capabilities that our public cloud side knows better than them, right? And so we're adapting two different business units to become one. The motivation behind that is a unified stack, right? And so that we literally have one software stack that is being deployed for our public and our private environments. And our operations team have one ecosystem to learn.
Yeah, so you want to concentrate everyone on the same product, even if it runs for private or for public, right?
That's right. Yeah.
Okay.
And so if you go digging in our documentation, one of the things is that we say we want it to be simple enough for hobbyists and scalable enough for large scale enterprise operations. And so actually quite literally behind me is a 3-node cloud, right? I've running on Lenovo 1-liter PCs. And it's running on our exact same stack that is running in our, you know, San Jose DFW and Virginia data center. So that like we're trying to make it so that if a customer wants a hyper-converged cloud, we can offer it to them using our solutions. If we want to build out our public cloud, we can offer it using our solutions. And we don't have to sit and hide like we had before with our internal private bits. So yeah, really, it is like embracing what OpenStack was always, I would say, was always intended to be, right? Is to be that open API, the open proliferation of infrastructure. And we're leaning into, you know, probably what we said a long time ago, but actually what we are actioning on that now.
On that topic, does it facilitate hybrid scenarios? Like, do you have business cases where someone that is a user from one would like to use the other, and it facilitates that transition because it's the same product, same API, same?
Absolutely, yeah. That's it. One of the big things that when we focus group this with our customer base, we were talking to them about, you know, what we're doing and what we're planning on doing at that time with the two different clouds. And a lot of them told us on the enterprise side, dollar for dollar, if you offered a public cloud that had the same API and capabilities, we would spend it on the public cloud versus going to an AWS or GCP. Because they already have their teams working on their, you know, their Terraform, their Ansible, their et cetera, in this OpenStack environment that is in their data center, and they need that burstability. And so, yeah, I mean, it does facilitate that.
David, you had a question?
Fire away.
Yes, sure. Thanks. Great presentation, by the way. It's great to catch up with what Rackspace has been doing. So I heard you talk about OpenStack Ansible and OpenStack Helm. Obviously, those are very different ways of deploying OpenStack services. I'm wondering how you use each of them to their strengths, or how you what you deploy, or what you find the best use case for each.
You know, like what I find the best use case.
So you're using the two of them right now, even for your new stack?
The new stack is almost all OpenStack Helm.
Oh, okay, makes sense.
Yeah.
Oh,
yeah.
All right. Okay. So I thought I understood it was both. So
no,
right.
We have two different products that are working on the two different solutions, and so we're merging those, and it will all be built off of the core. The underlying foundation will be Helm based of the new product. But I mean, OpenStack Ansible offers some really great customizations. Like, well, quite frankly, anything and everything that could be changed in OpenStack is available to be changed in OpenStack Ansible. The configuration options are plentiful. It does that does mean that there is a certain level of responsibility that happens when you go to deploy a cloud, and that responsibility does create potential frustrations. As one of the people who started that project, I can tell you about where the gremlins are. But what's nice about OpenStack Helm is that it's more prescribed. It's less, quite literally, it's less flexible. But that gap in flexibility it simplifies the approach, right? If you're starting out with Helm, you can have a good outcome without having to really change very much. It just kind of just works, like to quote Steve Jobs. But it kind of just works, and it works as intended, right? The documentation is okay, but the implementation is very good. We've addressed some of the lack of flexibility with Customize. So we're using OpenStack Helm with a post renderer that executes Customize on the backside, and that lets us change whatever we need to change or want to change for different drivers that we're implementing. For example, like we integrate with NetApp as a storage driver using the OpenStack Helm solutions, and that's not easily achieved natively. So it wants to use Ceph out of the gate, right? And we're not using Ceph by default.
You have people in your team able to manage OpenStack Helm as well as OpenStack Ansible. They can do both.
We do, yes. Yeah. So, but as we are moving this direction, we will pull the enterprise product portfolio into this new OpenStack Helm ecosystem.
Am I correct if I say that your previous stack was working with OpenStack Ansible and you're moving to OpenStack Helm, right?
That's correct.
Okay.
Yeah. Yeah, that's part of the enterprise side has to change just as much as our public cloud side to really form this new business unit, right? Like enterprise has been using OpenStack Helm for a long time, or sorry, OpenStack Ansible for a long time. Public cloud has been using their own systems for a long time, and we're converging on a new unified stack.
Cool. Mauricio has David, did you still have questions?
I was being thankful. Thanks.
No, yeah. Hopefully, it answered your question. Yeah.
Yeah. Thanks for this opportunity. You mentioned at some point that the migration from one environment to the other is being done in parallel. You actually building a new environment in parallel, just because you're unable to migrate from Zen to QEMU, right? Is that the correct understanding?
Yes, that is a part of the motivation, but yes.
Was that anything also related to the fact that you're moving from regular OpenStack to Kubernetes-based OpenStack or not?
No, not really.
No.
No, I mean, if we were to be using OpenStack Ansible instead, that is using LXC containers, it would be the migration story would be the same, right? Because the underlying infrastructure and API that we're moving to is 100% OpenStack, top to bottom, right?
Okay.
Where we're coming from is a highly customized version of OpenStack from 2012.
Okay. All right. Thank you.
Yeah, of course.
So, for example, we did such a migration from outside Kubernetes, where that's maybe not a deployment solution we were not so happy with, to a custom one, and that worked without any kind of downtime. It needs some kind of planning, of course, but
for sure,
like the backend, the actual implementation of the VMs of the network doesn't change.
Yeah, 100%. Yeah. So and I actually like leaning into advertising, not Rackspace, but Mohammed with Vexhost, right? They also used to use OpenStack Ansible a while back. Now they're using their Atmosphere tooling, and they've done I've been to a couple talks from Mohammed where they've talked about moving their environment to their new Atmosphere portfolio, and it has been very successful. Interchanging the backends because the implementation remains the same, right? And so customers don't know that it's necessarily changing. It just wakes up and has changed.
So I had one question around your approach to scaling. So you mentioned new regions, is that like a single zone? Is it zone versus regions? What's the size of a one cluster? How do you fragment it, and how do you up to what level do you scale, I guess, in one single region? And
yeah, we're using regions as the divider. So San Jose is region, DFW is a region, IAD's a region. Within that, there are availability zones. We have not actually reached the scale on the new platform yet to where we need to begin carving out availability, more than one availability zone at this point, though we are set up to do that when we need to. We have, though, divided a whole bunch of our regions in host aggregates. And so we'll have different generations of hosts all grouped by aggregates. One of the things, if you've followed any of our other press releases, our GPU as a service platform is actually all running on our San Jose data center in our OpenStack environment. And that is a host aggregate of GPU enabled machines, right? And that's all being fronted by Spot, but the underlying infrastructure for it is all 100% OpenStack on our brand new platform.
And so the number of hypervisors in a single availability zone, when is the level where you think you will hit scaling limits that force you to have multiple ones?
TBD, really. Historically, going off of what we had historically, we try to keep cells under 500 nodes, right? We're operating under a very similar mantra right now.
Yeah,
we have some supercells that were like 800 nodes, but they're also a super pain in the neck. So
yeah, somewhere between 200 and 1000 seems to be depending on, I guess, API traffic, how fast the machines are destroyed and remade, I guess, is really the factor that lets you be more precise. I think we had one question in the chat from Seongsoo. Is each region an independent keystone, or do they share a keystone?
They are independent keystones, but because we're using federation,
so you link all of them together.
Yeah, they're all linked at a global level through our IAM, right? But each region though is an independent keystone, and so we're not traversing the internet for token revocation or caching or any of that other jazz. So it is all independent. Yeah. So like there's no interconnectivity between San Jose and Virginia, right? Except for that through that IAM, which is how our federation works.
How do you manage quotas and stuff like this? And do you have some sort of script outside of this to?
We do, yeah. We have some operational tooling that will set quotas, but the two different regions are actually different sizes, and so we quite literally wanted quotas to be in somewhat different in San Jose versus like I said, Virginia or Dallas. So if a customer wants to be able to use hundreds of nodes in San Jose and thousands of nodes in IAD or vice versa, we want to be able to let them do that.
Mm-hmm.
But yeah, we have some operational tooling that does that for us.
You shared earlier that you're using cells to scale after some amount of nodes. Are these then all running inside a single Kubernetes cluster, or are you also using that as a board of a Kubernetes cluster?
It's all one Kubernetes cluster at this point. We have a management plane for our Kubernetes environment, but we aren't using like multi-region Kubernetes or multi. It's not multiple deployments all tied back into one. Kind of like the Rancher, where it has the cattle cluster and then you have your sub clusters underneath. Mm-hmm. We have not done that yet.
Mm-hmm. Because we are running one OpenStack deployment with like 1,600 hypervisors now in a single Kubernetes cluster, and it's just Kubernetes is getting a little overwhelmed.
Yeah, it's chatty.
At CD is running at like 80 cores or so. So
sure, yeah.
Maybe no longer that ideal.
Yeah. That's about 1,000 in our scale testing. Really trying to beat on it. About 1,000 is where we feel like there's a good divider between regions, but It really depends. I mean, with a lot of this modern hardware, right, and minimal overcommit ratios, so you can get a lot of density out of it. And so 1,000 nodes today is tens of thousands of nodes from just a few years ago. So, well, yeah, we are still learning in a big way.
And what I also found from the graph you shared, that you're using Cube OVN for is it then basically the overlay network for the Kubernetes?
Yeah, it is actually. So kubeOVN is being used for both OpenStack and Kubernetes.
So it's basically the same.
It is all the same.
Not separate. Okay.
Yeah, that's right. So a lot of approaches that we had seen previously were like setting up Calico on one side and using OVN on the OpenStack side and creating segmentations between them. It's all one network fabric for us, all through kubeOVN. KubeOVN, what do you want to call it? But actually the reason for that is because while we are talking about OpenStack here, we also have the ability to extend neutron routers into the Kubernetes space itself, right? Neutron routers become a VPC according to kubeOVN, and a VPC can be used with containerization tools. And so that's leading into where we're trying to take our platform as a service offering in the future, being able to operate virtual machines, bare metal, et cetera, using that OVN framework, but also being able to offer Kubernetes workloads or workers or software solutions to customers on demand. Again, from an infrastructure point of view, pointing at being able to use both simultaneously.
So we spent 37 minutes without asking a RabbitMQ question, but Ishan has one.
Yeah. No,
so please ask your question.
We can't hear you.
Yeah, we can't hear you. You're muted.
Queue config used in production, is it independent of the cluster and part of the cluster? Well, okay.
Yeah.
So there's actually two questions. One was Keystone DB is not replicated to each other. Correct. Each DB is isolated from every other DB, and the shadow users are under for Keystone Federation are consistently hashed across the different regions. So just FYI, if a user never logs into IAD, they'll never have an entry in IAD. And when they do, they will. So yeah, to answer that question about the Keystone database. As for RabbitMQ, happy to share it. Everything that everything, 100% of it is can be found in our GitHub repository. I will link you to it, and you can check it out. But the high level here is that we are using RabbitMQ with quorum queues. We are using the RabbitMQ operator with the RabbitMQ topology operator as well. And it is facilitating the interaction with those queues. And so each service has its own virtual host, but it is scaled independently with the RabbitMQ operator.
It's a single deployment of RabbitMQ?
It is a single deployment of RabbitMQ for the OpenStack namespace.
For the full region, but you use different just the rest. Okay.
So and there's the repo if you guys want to poke at it. But yeah.
Oh yeah, thank you.
But yeah, it is a single deployment of RabbitMQ per namespace. We do have segment different systems that are using RabbitMQ, and that is not just OpenStack by namespace. And so there are multiple deployments of RabbitMQ in our environment. But the OpenStack one is a single deployment with multiple virtual hosts, and the underlying framework is quorum queues.
So it scales independently of the OpenStack cluster, is it?
That is correct. Yeah, it's not uniquely. We're not using the OpenStack Helm charts. The Helm OpenStack Helm provides charts for RabbitMQ. We're not using that. We're actually just using the RabbitMQ operator as provided by Pivotal.
I don't suppose you guys are deploying RabbitMQ4, which was released sometime recently.
Probably not. I'd have to go back and check the actual version of what's in the environment. It is a really recent deployment of RabbitMQ, but I doubt it's that recent.
You said you were using quorum queues, right? For every event for the transient queues, you enabled all of this.
Correct. Yeah, we went through all of the OpenStack services and made sure that OsloDB was set up to be using quorum queues itself, as well as ensuring that the RabbitMQ operator was instructed to use quorum queues as well. For the
Do you know if you are using stream queues as well, or maybe not?
I don't know that off the top of my head.
I'll take a look at your GitHub. Maybe it's
I don't know that one off the top of my head, but I will find out.
So it's been 40 minutes and everything seems to be running really well. And you can't fool those operators.
Oh no, there must be some
challenges and concerns there. So what are the problems that you've run into and like the biggest pain in your rear, and what are some hiccups with that strategy, and we want to know all about it.
Yeah, so I mean, it's a fairly unique strategy, and so first problem that we run into is quite literally training everybody to get have an understanding of how actually all of this works. Because if you've ever seen Always Sunny in Philadelphia with the strings all over the board, and there's trying to draw a crazy picture, that's kind of how some of this came together as the engineers were developing the platform. And so the first issue is that cognitive one, right? It is a fundamental shift in how we are delivering bits from what Rackspace has done historically, both on the public and on the private cloud side, right? Where the teams have to come together to learn something new. So that is not necessarily a challenge, but it is something that we've had to grapple with, right? And preconceived notions of how things work, right? Like somebody logs in and they're like, how do I restart the service? I'm like, you delete the pod. And they're like, I don't want to delete the pod. I want to fix the problem. I'm like, well, you fix the problem by deleting the pod. So I mean, that is probably the first one. Technically, we've had quite a few, hiccups that we've had to kind of grapple with, offering Octavia, right? As a load balancer service, the Amphora driver works pretty well, but we also wanted to be able to use the OVN driver, and that offers a layer 4 very fast load balancer that's very close to the network. It works really, really well. But we've had issues where the definitions just go away sometimes if the driver crashes, and you're like, what else? And so we've had to, we've created strategies to restore things if this happens, right? And we've created, operator tooling to help us navigate those waters. But it was, when you're traveling the happy path, everything is working great, and then somebody, starts smashing your API really hard, and the driver crashes, or OVN doesn't respond in time, and it crushes your environment. Not necessarily the whole environment, but it creates a bad user experience, right? And so we've had issues like that. Early on, we wanted to offer. We wanted to offer modern virtual machine experiences for customers, right? So that meant, Q35 image types with UEFI boot, and being able to use all of the build hints that libvirt has built into it, right? And having the feature flags and functionality that OpenStack offers, right? As a property, you just add it to the image and it should work. But some of those packages, some of those drivers, some of those capabilities weren't actually installed in the base images that we were using. So we had to, go, and that was like a game of whack-a-mole of okay, UEFI works now, and okay, now this one works, and okay, now this one works. So there was a lot of learning that took place, at least early on trying to figure out how we can update the drivers so that we can support it for our new platform, right? And have those features and functionality. What else is there? We're offering encrypted images, encrypted volumes, right? So if a customer provisions a block storage volume, it's encrypted by default.
Is it using Barbican?
It is using Barbican,
of course.
But that created a new challenge because you can't live migrate with the default security policy with Barbican when you use encrypted volumes, which takes away some of the what you want out of as an operator point of view, right? Being able to tell customers, hey, we use boot from volume, gives us the instance HA functionality that you need or want for that instance, and it's encrypted. And they're like, this is amazing. And you're like, well, I have a host server problem. I need to move you over, and you can't do it. We had to change. We made some updates to the policy, and it fixed the problem. But the default was quite literally secure, so secure that an admin or an administrator couldn't help users move their workloads. So like these are bumps along the way that we've had to learn, as well as relearn. Really, it's like this actually might be common knowledge to a lot of people here on this call, but and actually I agree with the Barbican default, right? It should be secure. An admin shouldn't be able to read the key and restart my instance and things like that. But from an end user point of view, they're like, well, like I chose this because I want that instance HA functionality, and you're telling me now that it doesn't work. That at least before we went GA with all of this stuff, right? And we learned this in limited availability and with some trusted customers, but they were painful lessons to learn.
Let's hope it will work very well now.
Yeah, it works pretty good now. But I mean, it took a lot to get there, right?
Yeah, so. I imagine so.
Yeah.
Maybe one question: how do you push a new change on your platform? Is it a defined process? Can you maybe share it?
Yeah. So we're in the process of publishing our SDLC and how we do that. But I mean, internally, the way that we do it, we have a change request process that goes through an approval. Engineers look through it, stakeholders look through it, to see what the impact would be. We build the images. If there are changes to the images themselves, those go through a quality check that we have for an internal deployment. That's where we have like a private like a QE cloud, if you will, and we're constantly rebuilding things all the time there to test things out. And then if something does get through the change management process and the build process and through the internal review, it gets promoted and pushed out into our production environments. I mean, but yeah, anyways, like we actually have a multi-page document on quite literally our SDLC, and that will be public.
I believe because you're using OpenStack Helm on all of this new stuff, you are kind of using a Git as a source of truth for all your change, right?
We do, yeah.
Is it true as well for the compute side? I mean, is it managed?
It is.
Yeah?
Yeah.
So Nova Compute is running in a Kubernetes deployment?
It is.
Okay.
The only thing, there's one exception to us running everything in Kubernetes, and that is in Cinder, we're offering, using the LVM driver for iSCSI connections for capacity block storage solutions. And iSCSI doesn't run in a container. Don't ask it to run in a container. It'll never run in a container. The kernel developers have said it will never run in a container. So that runs on bare metal.
So you have specific Kubernetes nodes dedicated to this, which are managed outside of Kubernetes, basically.
Well, actually, even those storage nodes for that service is running on bare metal, but it is a member of the Kubernetes cluster.
Yeah. Okay.
So like there's different applications that are running on there that there are pods running in it, but there's a service for the LVM block storage solution that is independent of Kubernetes. And we have an Ansible playbook that deploys that.
Okay, you have a specific deployment and script to install this, provision script to install this. Okay.
Yep, and even that playbook is in our Genstack public repository.
Everything is on GitHub, right?
Everything is on GitHub, and it is all public.
Nice.
Yeah.
So.
Okay. Hi. I have a question about the monitoring. So, in your slide, you are monitoring the OpenStack with the Prometheus. So, how do you using the Prometheus to monitoring the OpenStack? Then you build your own exporters for the OpenStack?
We have a couple of exporters that we've created, but for the most part, the exporters that we need are available publicly, or they already exist, and so we're using them just as they are. So things like RabbitMQ that has its own exporter, MariaDB has its own exporter, and so we've taken the approach of why do we believe that we could be better than the people who create like rabbitmq to instead of reinventing that wheel, we'll just use what they're providing. And if we have issues with it, we provide feedback into those issues or code reviews or patches or etc. We've done that with like MariaDB and the MariaDB operator. I was pretty well plugged into that community for a little while as we were building out those solutions and telling them where it wasn't working or where it was falling over. Helm, there's a couple bugs out there that we've contributed to improve it, like specifically around how it handles post renderers and things like that. But for Prometheus, we are collecting all of the metrics, storing it. We're using FluentD to collect everything. We're using Prometheus exporters to collect the metrics itself, and then we're aggregating that internally with creating single views with Alert Manager for when we have host server down issues. We're bubbling up that information into again a public status page. If you go to status. I think it's status.sjc.rackspacecloud.com. You'll find the public status, and that is reading real-time metrics out of our Prometheus environment.
Okay, thank you.
Yeah, of course.
We do have a question in the chat around the Linux distros you use and how do you handle upgrading kernels and like the lower level distro that you're using as a base for your deployment.
Yeah, right now we're using Ubuntu as the base operating system, and so we're let's see, curious on what Linux distribution you use. Yeah, Ubuntu 2404 is the base operating system. We try to stick on hardware enabled LTS kernels. Right now, everything is running on some variant of 3.8. Or sorry, 6.8, so like 3.8. Yeah, it was like, hello, 15 years ago. But 6.8. We try to stay on those. I mean, when it comes to like rebooting hosts, if a customer has an instance that is running with that HA block storage, right, and has the ability to be live migrated off of a box, we do that. If not, we send comms that it is local storage, and the node will be offline while your instance will be offline while the node reboots. If we have to apply a patch, right, and we're taking a very active approach to patching. If there's a CVE, we're going to go fix it.
For example, what is the plan for your GPU instances? I believe you won't be able to live migrate instances on these hypervisors.
Yes, so a big motivation to getting to Caracal was the initial implementation of being able to do live migrations with GPUs. It works okay, but yeah, there are some troubles with that. And if a customer is on a box that is running in NVIDIA H100, hopefully we don't have too many issues with it that facilitate or require us to kick them off and move the boxes or whatnot. But if we can live migrate them, we do. If we can't, then we say very, very, very sorry and perform the maintenance.
How do you then handle things like changes to OBS or OVN control or Nova Compute on these systems? Do you just like rip them out and restart them quickly enough so hopefully nobody notices?
Sometimes, but for the most part, it's opportunistic, right? We lab them out, and if the impact is like we lost 10 packets, we're like, well, okay, like that. Maybe that's an okay change to make. If the implementation is like, well, we're down for 10 minutes, well, let's pump the brakes and create a rolling strategy so that we aren't creating a systemic outage across the platform.
Mm-hmm. And then probably the same for config changes as well.
Very much so. Mm-hmm. Yeah. Like we wouldn't want to go and sever the libvirt daemon. Like we want that one to stay alive.
Okay. Although, as I know from OpenStack Helm, I think you can just kill the libvirt part and everything will come back.
You can, yes, but like we wouldn't go and like forcefully shove it off and hope it gets rebuilt in time, right? It's like that would be customer impacting for especially for our high density nodes, right? Like if there's 200 VMs running on a box, I don't want to take down 200 nodes or instances because somebody was shooting from the hip, right? So yeah, we try to lab out what we can and make sure that those changes are at least not as impactful as they could be. But yeah, there are changes that have to be made, and those changes can be impactful. But
so we have 5 minutes left, and I wanted to make sure you had the opportunity to also ask your own questions to the other operators. Is there anything, Kevin, you want to ask Felix or Arno or anyone else on the call, like a question, curiosity you have about the OVH cloud deployment or the Schwartz group deployment or anyone else?
I mean, like, yeah, you guys are, you mentioned, using OVN. We're also using OVN. And I would love to know, what are some of the pain points that like, where are our blind spots, right? I mean, you could consider us a new player in this space. I mean, we've done a lot of good work on it, and we know, well, we know what we know, but we don't know what we don't know. And so we would love to know, where some of the pain points are. Specifically around like acceleration, right? Actually, in Korea at the Open Infra Days, or Open Infrastructure Summit in Korea, we went to a talk with Intel talking about using OVN or using Intel network devices to get accelerators to work within OVN itself for better scale and packet performance and things like that. And while I think we have a pretty good handle on it, we're always looking at ways that when we're building our next cloud, how to do that better. And so I'd love to know your opinions on where those ugly spots are.
Yeah, so currently at least we are running OVS with the normal kernel module and running packet processing on kernel space side as far as we can do. But we are planning to switch basically to DPDK as well as then vhost user processes to get everything of the packet processing outside of the kernel.
Okay.
On the one hand, to make it easier for us to do changes, and on the other hand, to also get a bunch of performance just by dedicating cores to the packet processing. So we are estimating what currently runs on maybe 50 cores will then run on maybe 3.
Oh, that's awesome.
But we didn't try too much of hardware offloading there yet. That seems to be sometimes better working with the kernel module, sometimes better working with the DPDK version. It seems extremely hardware specific.
Yeah.
I was also on the OVS Con a few weeks ago in Prague, and there was also a few talks regarding that. And I'm not sure if there's like completely common way for all hardware vendors to do things.
Fair.
It feels a very dispersed also on what the hardware has to offer as capabilities that OVN or OVS could offload there. So I'm not so sure yet what to do with this. I guess we'll try for us like what it can offload, but I'm not yet sure if it's like, can it offload 2% or can it offload 90?
Yeah, definitely. And then, I mean, is anybody actually at Open Infra Days in North America, there was a pretty good hallway track talk, not necessarily an actual talk, but a bunch of us talking in the lunchroom, but talking about like DPUs. Is anybody doing anything specifically DPUs, digging into P4 or anything there?
We tried Bluefield 2 versions from NVIDIA. They work quite well, but they were discontinued by then. And the new versions are like 400 gigabit NICs, which might be nice for special GPU workload. But at least for our general purpose hypervisors, I don't want to connect them with 400 gigabit. So like there's a mismatch between NIC performance that I would like and what NVIDIA is offering there. And management of these was a little interesting.
actually, and still networking, but also changing gears. Is anybody using like anybody else using multipath for block storage, or what's most people's preference in terms of the block storage? Is it fiber channel, NVMe OF, or over IP or iSCSI, etc.?
We currently run NFS.
Okay.
So with NetApp backends.
Yeah, that's fair. Yeah, we're doing iSCSI, but NetApp backends, right? And outside of the LVM driver, which is multipath and iSCSI as well. But it's just kind of curious what everyone else is doing and how you're dealing with some of the scaling issues for one versus the other.
We do safe on our side, and we are going to do NVMe over Fabric in a short term. Yeah, based on a technology we developed ourselves.
Awesome.
Yeah.
Very cool.
Okay, well, we're running out of time. Feels like we could have continued for a while.
Yeah.
Well, feel free to join us in future editions of this large-scale SIG virtual meetup, Kevin, so that you can ask all those questions to future guests and future participants. So thank you so much for being our first guest to this new format. I think that was really great insights, learning about how you approach the new Rackspace cloud and all the questions that we received. Feels like it was very useful to everyone. But thank you again. Thanks for everyone joining today. And I'm pretty sure we'll do another one. So I think it's a good format. So thank you all again.
Thank you.
Thank you for setting this up, Thierry. How do we make sure we don't miss the next one?
I will let you know, David.
Okay.
Yeah, well, we only posted it on OpenStack Discuss this time because I had no idea how many people would show up. We might do more of a social media announcement in addition to the OpenStack Discuss post next time to see if we get more people or a manageable set of people. But it feels like this was good. So probably not in December, but sometimes early next year, we'll probably find a new special guest and organize the next one.
Yes, it was great. Thank you again for having me on. And I was expecting more Festivus, but this was good. This was good. This is a good conversation. Yeah. So thank you. I hope you all have a fantastic rest of your day.
Perfect. Thanks, Kevin.
Thanks, everyone.
Cheers.
Bye.
Bye.
See you. Bye.